Hi everyone, this is Mrs. GA. Today we're going to be doing a review on how to solve quadratic equations. So before we start solving quadratic equations, I have this quick warm-up, so please pause the video and give it a try and then hit play when you're ready to check your answers. Alright, let's go ahead and check. So the first problem is a trinomial where your a value is 1, so I use that magic x method, and your factors should be x minus 5 and x minus 3. The second problem is difference of two squares, so you can use that formula. Your a value is x and your b value is 10, so x plus 10 times x minus 10. And for part C, we can use GCF. So we can divide both terms by 2x. Make sure you're also dividing out the x. And so our first factor is 2x, and our second factor is 2x minus 9. You just get that by dividing. So if you need some extra review on this, make sure to go back and watch my factoring quadratics review video. Alright, so there are a number of different methods that we learned for solving a quadratic equation. So the method you pick will depend on how the equation looks, and it might also depend on just your preference, because sometimes multiple methods will work for the same problem. So we're going to review the square root method, which works when you have an equation without that b term, so when you don't have any term with just x. This method works really well. We can solve by factoring, which is usually the quickest and easiest way to solve. However, you have to take note that some expressions are not factorable, so this method doesn't always work. We are also going to review completing the square. Now this method works best when your b value is even. So if my b value were odd, I probably wouldn't pick this method. And last is the quadratic formula, which always works. So this is a really important one to know. So just kind of visually, if you look over here, again, this is our standard form of a quadratic formula. When you're solving a quadratic, you can actually solve by graphing as well. It's not always as accurate, but it is possible. There's three cases that you can get. So remember, when you're solving an equation, you're really looking for the x values, which are the x-intercepts. So it is very possible that you have a parabola, which is what the graph of a quadratic function looks like, that never crosses your x-axis. So here you can actually get no solution. We're not going to be talking about those today, but we will be talking about those later on this unit. It is also possible to have the vertex on your x-axis. You only cross the x-axis once. So here is a case where you would have one solution. That's what it looks like graphically. And last, you can have a parabola that crosses your x-axis 2 times. So that would give you 2 solutions. So any of these are possibilities when we're solving a quadratic equation. Okay, so let's start by reviewing how to do the square root method. So it's pretty simple. Your first task is to isolate x squared completely, and then all you need to do is take the plus or minus square root of both sides and then simplify the radical when necessary. Just remember, whenever we are the ones taking the square root, like if you initiate it, you have to have that plus or minus in front. So please don't forget to add that in. All right, let's try this first example together. 3x squared equals 18. So notice here we have an x squared term, but there's no term with just x, so this square root method works really well. So first we need to make sure to isolate that x squared, and we can do that by moving the 3 using division. So divide both sides by 3, and we get x squared equals 6. So now that x squared is isolated, all we have to do is take the plus or minus square root of both sides. So a square root is the inverse operation of a square. So they actually cancel each other out, which leaves us with x on the left. And then on the right, we're left with the plus or minus square root of 6. Now, square root of 6 cannot be simplified. So this is actually our answer. So we can leave it like this, or you can write it as 2 different answers, square root of 6, negative square root of 6. So here's the positive and here's the negative. But it is really important that you understand, in this case, we do have two solutions, positive square root of 6 or negative square root of 6. But again, either way of writing the answer is totally fine. Okay, let's try one more together. Again, I see my x squared term and there's no x term, so that tells us the square root method is a great one to pick. So let's start by moving that negative 12 using addition. We'll move it to the right side of the equation. And we get this. And we still need to clear this 1/2, and we can do that by multiplying both sides of our equation by 2. So that leaves us with x squared equals 24. So now that x squared is completely isolated, we are ready to take the plus or minus square root of both sides. So this leaves us with x equals plus or minus square root of 24. So square root of 24 is something that can be simplified. So remember, we're going to try to factor this and think of factors that are perfect squares that might divide into 24. So first perfect square I think of that divides in is 4. So we can do 4 times 6. So we know that the square root of 4 is 2. Again, here's what we have left. So the square root of 4 is 2. And then square root of 6 just stays square root of 6. So our final answer is plus or minus 2 root 6. Again, we can write this as positive 2 root 6, negative 2 root 6, or we can leave our answer like this. As long as you have that plus or minus and you understand that there are two answers to this equation. Okay, so now we're going to try that second method, which was solving by factoring. So the most important step when we solve by factoring is that we make sure that we first set our equation equal to 0. This method will not work if our equation is not equal to 0, so make sure you do that first. And then you look at the expression and you see if it is factorable. So if it is, factor it using the methods that we reviewed in the previous video. And then once it's factored, we're going to use the zero product property to finish solving. So that's where you take each factor separately and set it equal to 0 separately and finish solving, which is why it's so important that you do step 1. We couldn't do zero product property if our equation was not equal to 0. All right, let's try this first one together. So here our equation is already set equal to 0, so I'm going to look at it and see if we can factor. So since I see that it's just two terms and it's subtraction, we're definitely going to check for a difference of 2 squares, which does work because 16 is a perfect square and so is 1. So our a value would be 4x, our b value is 1, and the factors are 4x plus 1 and 4x minus 1. Remember, a plus b times a minus b. So now that our equation is factored, we're going to use the zero product property, and we're going to take each factor and set it equal to 0 separately, like this. And then from here, we just finish solving. So here we can subtract 1 from each side, and then divide by 4. So x equals negative 1/4. That's one of our solutions. And here we can add 1 to both sides. So we get 4x equals positive 1, and then divide by 4. So x equals positive 1/4. So again, we have two solutions. And since they're the same values, but one is positive, one is negative, if you'd like, you can rewrite your final answer like this. But leaving them separate is totally fine as well. All right, let's try another one. So here again, our equation is set equal to 0 already, so we're ready to factor. So the first thing you should always check for when you're factoring is a greatest common factor. So in this case, the GCF, the biggest number we can divide into both terms, is 7x. Don't forget about the x. So make sure to write 7x first, and that leaves us with x minus 2 equals 0. So now we're ready to do zero product property. So the 7x is a factor, and it actually has an answer trapped inside of it. So you also need to set this equal to 0. So we say 7x equals 0, and x minus 2 equals 0. So here, if we divide both sides by 7, we still get x equals 0. That's one of our solutions. And on the right, if we add 2 to each side, we get x equals 2. So the most common mistake that people make with this type of problem is forgetting to either write their GCF in their factors or forgetting to set it equal to 0. Just remember, it is a factor, so we need to include it when we do the zero product property. All right, so here we have x squared minus 2x equals 8. So hopefully the first thing you notice is that your equation is not set equal to 0. So we have to fix that before we try to factor. So we can fix that pretty easily. We're just going to move the 8 using subtraction. So this gives us x squared minus 2x minus 8 equals 0. So then this we can try factoring using magic x because it is a trinomial and our a value is 1. So we're looking for two numbers that multiply to make negative 8 and then add to make negative 2. So we can use negative 4 and positive 2. So our factors are x minus 4, then we have times x plus 2, and it is still equal to 0. Now we're ready to do the zero product property. So we take each factor and separately set it equal to 0. And so here we get x equals 4 and x equals negative 2. All right, let's do one more solve by factoring. So here we have negative 2x squared equals 13x plus 6. So here our equation is definitely not set equal to 0. And just strategically, we would always like our x squared term to be positive. So rather than moving these two terms to the left, if we move this single term to the right, then x squared becomes positive and our equation is equal to 0. So it's kind of a win-win. So let's start by adding 2x squared to each side. So remember, we would always like our x squared term to be positive. So 0 equals 2x squared plus 13x plus 6. So now this is something that we can try to factor. It is a trinomial, but our a value is greater than 1, so we can try using that grouping method. So remember, we're looking for two numbers that multiply to make 12. We multiply these two numbers. So we want two numbers that multiply to make 12 and add to make 13. So we know that those two numbers could be 12 and 1. 12 times 1 is 12. 12 plus 1 is 13. So we're actually going to be rewriting 13x as 12x plus 1x. So when we do that, I like to put the outer terms first, like this. So now we need to decide which term to put first. So if I look at 1x and 6 don't have anything that they're both divisible by, but 1x and 2x squared, at least they're both divisible by x, so they do share that. So I'm going to put the 1x first and then the 12x second, because 12x and 6 are both divisible by 6. So then we can group. So we're going to group the first two terms and the second two terms, and we're going to look for a GCF. So for the first two terms, our greatest common factor is simply x. So we have x times 2x plus 1. And for our second two terms, the greatest common factor is 6. So then we have plus 6 times 2x plus 1. So since these two terms, or these two factors, are the same, we know that we did this problem correctly. And it also means that we can take x and 6, the coefficients, and they become our other factor. So we get 0 equals x plus 6 times 2x plus 1. So those are our two factors, which means we are ready to do zero product property. So x plus 6 equals 0, 2x plus 1 equals 0, x equals negative 6, 2x equals negative 1, so x equals negative 1/2, and those are our two solutions. So again, if factoring a trinomial like this was a little bit tricky, please make sure you have gone back and watched that factoring review video, because I do discuss how to do that in more detail. All right, so now we're going to move on to the next method for solving, which is completing the square. So this process is a little bit more involved, and you do need to know the steps. So make sure you have this to reference as we're doing the next problem. But essentially, the first thing we're going to want to do is to put our equation in this form. We want x squared and x on one side, and we want that c term, the constant, on the other side. Then we're going to be looking for what I like to call the magic number. So this magic number is the number that's going to complete our square, and we can find it by using this little formula. So you have to have this formula memorized. It's b divided by 2 squared. So you take this value, you cut it in half, and you square it. So once you find that magic number, you're going to add it to both sides of your equation. And then you should be able to factor the left side of your equation, and you should end up with a binomial squared. If you don't, then you didn't add the correct magic number. Once you have that, we're going to take the plus or minus square root of both sides and then finish solving for x. So again, see if you can reference this list of steps as we go through the next example. All right, so here we have x squared plus 6x minus 5 equals 0. So remember, the first thing we need to do is put our equation in the correct form. This constant, we need to move it to the other side. So we're going to move it using addition. We can add 5 to each side, leaving us with x squared plus 6x equals 5. So now we need to find the magic number that completes our square. So we do that with that formula. I'll do it on the side. Remember, our formula is b divided by 2 squared. In this case, our b value is 6. So we do 6. We divide it by 2, which is 3, and then we square it, which is 9. So 9 is our magic number. We're going to be adding it to both sides of our equation. Don't forget to add it to the right side as well. So here we get x squared plus 6x plus 9 equals 14. So now our next step says to factor the left side of our equation. So we're going to factor this. Again, we can factor this using magic x, what two numbers multiply to make 9 and add to make 6, 3, and 3. So you should end up with the same two numbers, which gives us the same factor, x plus 3 squared. So you should end up with the same factor twice, and we're going to write it like this. So x plus 3 squared equals 14. Now we can get rid of this square by taking the plus or minus square root of both sides. Don't forget that plus or minus sign. And that leaves us with x plus 3 equals plus or minus square root of 14. And now we just need to finish solving for x. So we're going to subtract 3 from each side. Here, this is a radical. This is a non-radical. It's a not square root. So you actually cannot combine them. So we're going to leave them as two separate terms, just in the order you see it. Negative 3 plus or minus square root of 14. And this actually, or these are our answers. So it's kind of an ugly answer, but that is the solution to this equation. Now it is important to note, again, this is two separate answers. So if you'd like, you could rewrite it as negative 3 plus square root of 14, negative 3 minus square root of 14. But please make sure you have that plus or minus sign in there, because this is technically two answers. So if you don't have it, you're missing one of your answers. All right, and now we're going to review that last method, which is using the quadratic formula to solve. So this is probably the most important method to know. And the reason why is that it will always work. So it doesn't matter what type of quadratic equation you're given, this formula will always work. So it's kind of your go-to. So if you have the equation ax squared plus bx plus c equals 0, your equation needs to be set equal to 0. The formula to solve for x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So one thing I want to point out is this negative b is part of the numerator. So a lot of people, it kind of ends up floating outside of the fraction. You need to make sure it is included as part of your numerator. And then once you, so if you know your a, b, and c values, which you can pull from your equation, you're really just substituting them into the formula and simplifying. So it might take a little bit of time to simplify, but these problems aren't hard. They're more tedious than anything else. All right, so let's look at example 8 together. So first thing to notice is that our equation is not set equal to 0, so that should be the first thing that we do. So it's an easy fix. Let's add 21 to both sides of our equation, giving us x squared minus 10x plus 21 equals 0. So when I'm doing a quadratic formula problem, I like to list out what my a, b, and c values are. So I see here that a is 1. A is always the coefficient of x squared. B here is negative 10, which is always the coefficient of x. And c is 21. So now all we need to do is plug it into our formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So notice anywhere that I substituted, I put the numbers in parentheses. Now we can just start simplifying. So first thing to notice is that negative 10 becomes positive 10, plus or minus. Here, negative 10 squared is positive 100 minus 84 all over 2. So let's keep simplifying inside our square root. X equals 10 plus or minus the square root of 16 all over 2. And we know that 16 is a perfect square, so x equals 10, square root of 16 is 4. So 10 plus or minus 4 all over 2. Now from here, we do actually need to set up 2 separate equations, one for 10 plus 4, one for 10 minus 4. So let's make sure to do both like this. So x equals 10 plus 4, and then divide by 2. X equals 10 minus 4 divided by 2. So 10 plus 4 is 14 divided by 2 is 7. There's our first solution. And 10 minus 4 is 6 divided by 2 is 3. So x equals 3. So we don't always end up with nice whole numbers for these types of problems. In fact, this problem we could have solved by factoring. That probably would have been a much quicker way to solve, but I did want you to see the way to solve a problem like this using the quadratic formula. But again, you will not always end up with nice whole numbers like 7 and 3. All right, let's try another one together. So here we have 5x squared minus 4 equals negative 6x. So first we need to make sure our equation is set equal to 0. So I'm going to do that by adding 6x to each side. And when I do that, I'm going to make sure my terms are in the right order. So x squared and then x and then my constant. So that leaves us with 5x squared plus 6x minus 4 equals 0. All right, so I like to, again, list out my a, b, and c values. Here, a is 5, b is 6, and c is negative 4. So let's plug it into the formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Then we just start simplifying. So negative 6 plus or minus the square root of 36. Be careful here because we actually have a negative times a negative, which gives us a positive. So plus 80 all over 10. Then we have x equals negative 6 plus or minus the square root of 116 all over 10. Now here in simplifying, we do want to make sure that we check to see if we can simplify this radical. So we have square root of 116. So again, try dividing it by some perfect squares. So actually, if you divide it by 4, which is a perfect square, you get 29. So it's 4 times 29 is 116. So that gives us 2 root 29. So we get x equals negative 6 plus or minus 2 root 29 all over 10. And then we do have one more step. Here you might notice that these three terms, and it does need to be all three, are all divisible by 2. So since all three of our terms are divisible by 2, and notice I just highlighted the coefficient, not the radical, we can simplify this a little bit more. So let's divide them all by 2. We get x equals negative 3 plus or minus square root of 29 all over 5. So here's a perfect example of when you don't get a nice, neat answer. I know it looks really ugly, but this is our answer, and this is the most simplified version. So again, it is 2 solutions, one for the positive root 29 and one for the negative. All right, here is our last example. So here our equation is set equal to 0. Now I know it doesn't look like the ax squared plus bx plus c because we're missing that middle term, that b term, but that's okay. We can still do the quadratic formula. So here our a value is 3, our b value would just be 0, and our c value is negative 4. So I still highly recommend listing out what a, b, and c is. So it's okay if you are missing a b or a c term. You can still use quadratic formula. And now let's plug it into the formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's start simplifying. The 0 we don't need to write, so we just have plus or minus square root of 0 squared is just 0. So here we just have negative 4 times 3 times negative 4. So be careful, make sure your answer does become positive. And we get 48 all over 6. And let's see if we can simplify square root of 48. So we know that 48 is 4 times 12, and we know that 12 is 4 times 3. So 4 times 4 times 3. So we can actually simplify both of these out. So square root of 4 is 2. This square root of 4 is 2, or you can think of this as square root of 16, which gives you 4. So 4 root 3 is the simplified version. So x equals plus or minus 4 root 3 all over 6. And then since both of these numbers are divisible by 2, we can simplify a little bit more. X equals plus or minus 2 root 3 over 3. So my last tip for these types of problem is don't skip any steps. Take the time, write out your a, b, and c values. Substitute the values with parentheses, and then just simplify one step at a time. I usually see that when people try to skip steps or do things in their head, that's where small mistakes are made. So if you take the time and you show out each step, these should be no problem. Just make sure you're always checking to see if you can simplify your answer. All right, so that's all for today's video. Thank you so much for watching.